Hello, good day to everyone, and I welcome you to the another episode on mold flows, tips and tricks. I hope you are enjoying the workflow and the ease of use and the explanation given into the few of the earlier clips. So today's session is in continuation to the earlier episode on validating the design in Fusion 360 before we go for the final flow simulation or mode flow simulation. I demonstrated how you can check on to the undercuts, draft angles, thickness and address at the design level. Now in this episode, we will continue how within the Fusion 360 itself we can do the upfront quick flow simulation. Again, the intent is to address the personas like designers and engineers who spend their 80 to 90% of their time onto the design, but at the same time, they want to use the flow simulation for the quick validation of the design. So keeping those things in the mind, the GUI and the graphical interface or what we call or the ease of use has been designed in that way. So with that, let's get started with it. As you can see on your screen, I'm using the same part that was being used for the quick assessment of the design. How do we push for this part from the design space to the simulation space? So with that, probably we go from the design space to the simulation, and as I mentioned in the earlier videos or earlier clips that you should have an access to the product design extension, and for the simulation you should have an access to the simulation extensions. How do we go for it? Is that you should go into the extension and then you should look for that I should have access to the simulation extension. Okay. So I'll show you first how do we get started with the setup. Let me open a quick file. So, okay, yes, okay, so I open a quick file on it, and let's get started. How do we create a first setup, and then I'll show you through the designed interpretation part of it. So I'm moving into the simulation space. Let me first put this as I don't know like what select setup is showing. It should not show the setup actually. Oh. Okay. So we are here, and then we will get started. I'll delete one of the setups. Okay. And then delete this as well. Okay. So I'm very clean on the setup. As soon as I get into the simulation space, I should get this GUI over here of creating a new study. Now there is an option of like simplifying the geometry. You can go and try simplifying it if you want to remove the radius also. So least be bothered that you are working on a simple part or a big assembly. Okay. So in this case, it's assembly, but we will see how we can isolate the required part from the assembly. And I'm going to choose upon the injection molding from here. And you can, if you want, you can go for the simplifications, but I'm going for the injection molding simulation over here. And that's what the newly introduced that have it from the month of January that's been introduced. But to access this, you should have an simulation extension as a part of your Fusion 360. Create a study. and as soon as you click on that create study, it will ask you to target the body. Now you can see that my part or the whatever that I have imported, it's an assembly. It consists of multiple parts over here that has a, the fixing bolts, the gaskets and stuff like that. But I'm interested in this housing, so I selected the housing, click on it, OK, and then that's the one that I ask you to select the target body. Now, as soon as you target the body, try to rotate it. The injection locations get automatically set up. So that's what it does in the background. It runs the best gate locations, and then the by default, the center of the part is chosen as the gate locations to get started with it. Now you have options to change the gate locations or alter it or add the gate locations. We'll come and I'll show you into the few minutes. The next thing, we have to just follow from left to right the sequence. The thing is the material. Click on the material and we should get an access to the material library. Now this is a online material library, so I would recommend that you are connected to the internet all the time when you are using these simulations, because you will get in the latest library. And as you can see, you have an access to the 12,385 material database, which is equivalent to the or same as that you will see in any of the Moldflow product. Could be a Moldflow Advisor or a Moldflow Insight. Now here again, repeating again, here we have kept the personas as designers and engineers in mind. So even the way we search the material has been simplified a lot. Like for this part, I'm going to use a polyamide 66 material. Okay. Now from the 12,385, it will go and search for which are the materials that are polyamide or APS66. And further, you have an option over here of selecting whether you want a specific filters to be put. If you know that I'm looking for the specific material or resin company or any of the based on the fillers, like in this case it's a fiber fill material, so I'm going to choose as a filler material. And glass fiber, I will also enter the glass content as 30%. So it will just narrowing down and a very simplistic way of doing it. You can see that now from the 12,385 material, I am narrowing down to 123 materials, and I can choose that, hey, this is what I was looking for the material, and I can look at the properties for this material. This is only for your reference, to not get into the details of so. Okay. And then you can return back, and probably if you are working a lot on this material, every time when you import the part, you can say that, hey, set as a default. So every time when you import the part, it gets default set. So gate location by default is been taken. The material is also taken. So probably you can just go and start the analysis. Or probably I already added it in my favorites. So you can see in my favorites, I added a few of the materials. You can add those materials in your favorites as well. So I'm going to choose from this material and say, okay, select. So that gets assigned to my part. You can see the details of it over here. I have assigned. The same thing is understanding the boundary conditions. Now, at the beginning, I showed you that the best gate locations is already been set over here, but you can always alter it. You can move it wherever you want it. Like in this case, I'm going to move this guy probably little bit closer to the edge. Okay, and then I can add another like a couple of that at like a 60 degree to it, and then so okay, and okay. So that's take me like the injection location. Don't be getting so precise that, because this is a very early validations where you don't have the and then You can also go and select for the aesthetic faces. So select the aesthetic faces which are of interest to you. Probably a thing marks may come or so. And so I'm just selecting those areas which are of interest to me. I selected you can opt the chain selections or just select the rest of the faces. And then the flatness of these face is important to me, so I selected this face as well. So it's an engineering component where I'm going to put a gasket, so I need the flatness to be of importance for me. Hit OK, and it highlights those faces which are of interest in the green. Then in processing conditions, you can go and select as an automatic or a specified one. If you know that, hey, this part to be molded at in a 1.5 seconds or 2 seconds, you can specify. Or if you don't know that, then probably you can just click on the automatic, and the melt temperature has been taken from your material library. The shrinkage allowance is also been taken from the material library. You do have an option of changing it. You can see that it also shows that the recommended 280 to 300, and for the mold temperature also the recommendation is been set. Click OK, that's all. And when you go and click it, probably yes, its study is all set to run, and then you can go and solve it. Now all of the study that you are going to run, all the studies that you are going to set are going to run on a cloud. Okay, there is no running of the case studies onto the local machine. So your local machine is quite free to do other things. And once you buy the subscription for the simulation subscription, additionally you get an access to do the structural simulation as well as the injection molding simulations, and it remains unlimited. Literally means you can run as much of the studies you want throughout, or multiple studies. There won't be any specific charges for it when you are subscribed to it. So let's go and solve it. I already solved the studies for you, and let's look at the results. So I am going to look at into another study over here. Okay, open it. And that's already run. So let's go and review the results for it. So in this case, what I did for the comparison purpose, I ran 2 studies. The earlier study that I ran was having a 3 gate locations at the top, and then another I ran was at the edge. I want to see that what makes the difference, which results makes more sense, whether to have the gate location at the top, which is in a centroid. Everybody recommends it, but want to go and try the gate location onto the side as well. So first we will go and activate my earlier study. Okay, that's what the having a 3 gate location. Once the analysis is completed, you'll get a pop-up that the analysis is ready, and you will also see that the green tick mark that the results are available. Now all of these results will also reside on the cloud. Probably it takes some time to download the results, and if you have a good bandwidth, it should be okay. And click on the results. And the results should get downloaded. So it shows that yeah, it's fetching your results, and here you go, your results are getting downloaded. So already the filling results has been downloaded. Now it is fetching the results for the visual defects and the warpage. So be little patient as it download the results. I'm doing everything online as it happens in actual running the simulation. And you can see onto the right hand side, you'll see a legend which shows that unlikely to fill, difficult to fill, and easy to fill. What does it mean? That if you put in gate locations based upon the processing conditions. It shows that it is likely to fill, means there is a high confidence of filling the part with those processing conditions given with the part geometry. It's little difficult to fill, okay, with those areas which are represented with the orange color, and then the red one that highlights is like unlikely to fill. So does it mean that it is going to have a short shot? Probably sometimes yes, yes. So you should be a little cautious and maybe giving a you know caution that probably I may get a short shot. If a short shot is going to happen, this could be the reason. And now let's go and look at what could be the next steps to be done. Onto the left hand side of your screen, you can see that what things can be done to improve it. Increase the temperature at the flow front. You can edit the process parameter. So this sounds to be very useful for the product engineers and designers who are not the analysts but wants to get onto it. The second thing is onto the visual defects. Since at the beginning of the analysis we have defined the faces which are critically important for me from the aesthetic as well. So simulation will go and highlight the probably there are any chances of seeing marks or not. On the right hand side you can see a scale, and I'm just trying to put it the scale from 0 to 0.1. It shows that hey, I'm getting a seeing marks in this range. The maximum is log of like in 0.12 mm, and also I can visualize it probably for the visualization purpose, and there is an option if you want to clearly visualize it. I would say that you need to change some parameters, make the little magnification higher, and instead of rougher, make it smoother so that it shines over here. Now you can see that it's clearly getting shined, and then you will able to see the seeing marks very clearly in these areas. And yeah, just try to get the light reflected from those, and you should be able to see the seeing marks actually very clearly. If it is not getting clearly visible, probably I would recommend increasing the magnifications, and you should be able to see that. Does it mean it is in actual reality is going to look like? No, I'm just increasing the magnifications to do that. In actual reality, probably you'll not able to see as well. You can see that it's not hardly any visible of that. So the other thing is that again next steps are there, and then look at the warpage results, and it shows the right hand side again the tolerance value, which is showing that what is that between 0.36 to 0.4, and this is the area that has a warpage in this region. Well, you can go and check the flatness because that's of very important for me. I want to check the flatness, so there is an options to check the flatness, and I click on this one face, and it shows that hey, whether it is flat or not, and it says that hey, it's almost like 98% flat if you are in the tolerance of 0 to 0.09, but if your tolerance is getting reduced, your flatness gets reduced. So that's because I'm increasing the tolerance, but obvious. So that was pretty much, you can try it for the different faces, all of the different flatness you can try it, and so even for the ribs also you can try it. Very interesting, and that gives you a fair idea to the designers, engineers, whether my face is going to be flat or not, or whether a fitment is going to happen, and what should be the tolerance for that, and you can go and change that. So that was pretty much, and then we have a much detailed results to be worked upon. So we will go and check on to the molding, and you can see it shows the complete molding process from filling to the packing to the final shape, as well as it also shows the tentative filling time and then cooling time and so on and so forth as well. But these are all the tentative results. Very interestingly, so you can just run the animation and see that how the part is filling, then how is the cooling and packing happening, and the final shape of the part that's to be taken out of this. Then we will go and click onto the detailed results. Now this is very similar to the any of the mold flow results, and you can see the filling pattern that is happening, and you can able to see how the filling happening. There is no way that you can stop in between, but yeah, I mean to say you can pause it in between like this, but I cannot scale it also like we used to do it into the other mold flow. But obvious, again the personas that are kept in the mind is the designers and engineers. So, and then probably you can look at the flow front temperature, and the one thing that was highlighted at the time of when we are reviewing the geometry, it shows that there are probably a chances of short fill. If you look at the temperature flow front range, it ranges from 261 all the way goes to the 200. There's quite a significant drop from the rest of the things. You can put an inspection and try to see that the temperature at each and every location, and why. Okay, let me move this, and here probably it's dropping a lot actually, and I will just try to scale a little bit down, and you can see that could be the reason, because the temperature is dropping high over here. That is the reason that it is showing that there is a possibility of short fills. Okay, if we can improve it, let's see if we can change the gate location and try to improve it, that can help. The other thing that I found it useful is the time to reach ejection temperature, because this is completely driven with your product wall thickness. If your product wall thickness is high, possibly you will get assuming a uniform mold temperature, that is when we specified at the beginning of the analysis. So it's assume a uniform mold temperature, and the rest of the calculations are purely done onto the product wall thicknesses, and you can see that this is the area which requires significantly high cooling time compared to the rest of the part. And then volumetric shrinkage at ejections, you can try and check it out. And the good part is that if the inspection probe remains same at that point when you are changing the results, so this could be very helpful as well. CMark depth, we saw how it looks like into the visual form, but there is an estimate where the people have requested, and just go and delete all the props so that I can create a new one, and I can see that I want to create a prop over here, and here I want to see that what's the magnitude of it. So you can create the prop and have a look at the results for the CMark. The interesting part of it was deflection all effect. Now it shows a very similar warpage results as that you will see in the advisor or inside. Again, it's a product based upon the product wall thickness and the specified processing temperature and gate location. And 0.36, what we saw that this is what we seen at the time of when we are evaluating as a guided results, and we saw that it was showing that the range of 0.36 to and this was the area. Okay, just delete this probe sign so that I can create a new one. And there is an options to magnify as well. So if you want that magnify it, you can magnify it and see that how the warpage is happening over here. Okay, this was pretty much. I want you, if you want to try it yourself, it's pretty easy. I have shown each and every step, but the one thing that I want to show is the interesting part is, as I said that at the beginning, I ran the analysis with the two sets, one with the gate location in the center and another was into the gate locations onto the edge of the part. I can do the comparison. I am doing it for the study 1. I can put the study 2 over here, and I can look at the, so it is also fetching the results, so give some time, and deflection all effect, and we are going to put it onto the same thing, and we'll able to see whether the choosing the second gate locations is helpful or not. So we'll put the same interesting range of like 0.36. Yes, 0.3. Both are now onto the same scale, and you can see that the part onto the right hand side is better as compared to the left hand side, because I would achieve a better flatness with this one. So that was pretty helpful. By just changing the gate locations, I would be able to do it. So I hope this demonstration took a little longer time, but you can do the comparison of the multiple gate locations or materials as well, and try it out, see. And from the next clip, we will start looking into the what's new in Autodesk Moldflow 2023. Till that time, take care of yourself and talk to you soon again. Bye.